Having already done polynomial addition, subtraction, and multiplication, it should come as no surprise that the next thing we're going to try to do is divide polynomials. And in order to look at how we're going to do this, we will start by looking at our regular long division and use long division to figure out how we could do long division with polynomials. And after we look at long division with polynomials, we will look at a simpler method for dividing polynomials. So we'll take a look at this simple division problem where we're dividing 12 into 2,549. And the first question we ask is how many times does 12 go into 2? Well, none. Then how many times does 12 go into 25? It goes in twice. 2 times 12 is 24. We subtract, and we get 1. And the next thing we'll do is we'll bring down this next 4. How many times does 12 go into 14? It goes in once. And we'll say that 12 times 1 is 12. We subtract, we get 2. Bring down this 9. How many times does 12 go into 29? Well, it goes in twice. 12 times 2 is 24. We subtract, we get 5, so we've got a remainder of 5. Now looking back at the original problem, I want to look at what this answer means. It means that if we take 2,549 and we divide by 12, our answer is 212 and 5/12, because that 5 still needs to get divided by the 12. We just weren't able to do it without resorting to decimals. So having looked at that, we'll look at a very similar problem with polynomial division. Now here we're dividing x plus 2 into 2x squared plus, 2x cubed plus 5x squared plus 4x plus 9. And we will end up seeing that this is in fact exactly the same division problem we did before, because it's really 1x plus 2, matching up with 110 and 2 1s, dividing into 2x cubed, matching up with 2 thousands, 5x squared matching up with 5 hundreds, 4 x's matching up with 4 tens, and 9 1s matching up with, well, 9 1s. Now the question that we ask ourselves as we go through this division process is a little bit different, but the result is going to end up being the same. So for my first step, I'm going to ask how many times does this x go into 2x cubed? Well, 2x cubed divided by x is going to give me 2x squared, so I'm going to write that up here. And then right down here I'm going to say, okay, what is 2x squared times this whole x plus 2 piece? And that's going to give me 2x cubed plus 4x squared, and I'm going to subtract, and we should see a lot of numbers matching up with the long division of numbers problem. And when I subtract, I'll get, well, 2x cubed minus 2x cubed is 0, 5x squared minus 4x squared is an x squared, and I'll bring down this 4x. Now I'll go back and I'll ask myself, okay, now how many times does this x go into this x squared? Well, x squared divided by x is x, so I'll have a plus x. And then I'll multiply the x again by this entire piece right here. And so I'll get x squared plus 2x. I'll subtract. Again, I should see numbers matching up. X squared minus x squared is 0. 4x minus 2x is 2x. I'm going to bring down this 9. And finally, I will ask myself, okay, how many times does this x go into this 2x? Well, it goes in twice, so I'll say plus 2. And I'll multiply the 2 times the x plus 2. I get 2x plus 4. Subtract, and I'll get 5, so I'll get a remainder of 5. And as we can see, all of the numbers in the division problem came out just the same in each problem. The meaning is a little bit different. So let's take a look at what exactly this means. So this means that 2x cubed plus 5x squared plus 4x plus 9 divided by, I should use parentheses here, divided by x plus 2 is equal to, well, 2x squared plus x plus 2 plus this remainder of 5 has yet to be divided by x plus 2. So this would be the result of my polynomial division right here. As you can see, 212 and 5/12 is taking a similar role to 2x squared plus x plus 2 plus 5 over x plus 2. So polynomial division, polynomial long division, and long division of numbers are performed in pretty much the same way. We'll take another look at an example of this, maybe somewhat more complicated. Now we'll look at a division problem that's a little bit more complicated. As you can see, the divisor is a quadratic and the dividend is a quartic. And of particular note, in the dividend there is no x cubed term. And you're going to see how we're going to deal with that as we write out the division problem. So here's our division problem written out, and as you'll notice, I put in this 0x cubed term. It's a placeholder, sort of like if I wanted to write out the number 30,217, I do need that 0 in the thousands place. And let's go ahead and take a look at this division problem. And the question I'll ask myself is, what am I going to multiply my x squared by to get to 3x to the fourth? The answer is I'm going to multiply by 3x squared. And we'll do 3x squared times our divisor, and I will get 3x to the fourth plus 3x squared minus, 3x cubed minus 6x squared. And I will do my subtraction here. 3x to the fourth minus 3x to the fourth is 0. 0x cubed minus 3x cubed is negative 3x cubed. And negative 2x squared minus negative 6x squared is plus 4x squared. And then I'll bring down my x here. Now I'll ask, okay, what am I going to multiply x squared by to get to negative 3x cubed? The answer is negative 3x. And then I'll multiply negative 3x by my divisor and get negative 3x cubed minus 3x squared plus 6x. Do my subtraction, and I will get 7x squared minus 5x. And bring down this minus 7. And then I'll ask, okay, what am I going to multiply my x squared by to get to 7x squared? The answer is 7. And I'll get 7x squared plus 7x minus 14. Subtract, and I get negative 12x plus 7. So I've got a remainder of negative 12x plus 7. And what this means in terms of my original problem is that 3x to the fourth minus 2x squared plus x minus 7 divided by x squared plus x minus 2 is equal to 3x squared minus 3x plus 7 plus negative 12x plus 7 over x squared plus x minus 2. Whew, just had room. Alright, and that's how we do a somewhat more complicated long division problem. Now I'm going to introduce a new method for dividing polynomials that we call synthetic division. I'll start by doing the same problem with long division first, then do the problem with synthetic division just beside it, so you can see how the two methods compare. So here we're dividing x minus 3 into x cubed minus 4x squared plus 5x plus 1. And I ask, what do I multiply x by to get to x cubed? I'm going to multiply by x squared. And multiply the divisor by x squared. I get x cubed minus 3x squared. Subtract. And I will get 0, and I will get negative x squared. I'll bring down a plus 5x. And I multiply x by negative x to get the negative x squared, and I'll get negative x squared plus 3x. I subtract, and I get 2x. Bring down the 1, and I'm going to multiply x by 2 to get to 2x, so plus 2. I'll get 2x minus 6. Subtract, and I get 7, so I'll get a remainder of 7, meaning that if I do x cubed minus 4x squared plus 5x plus 1 divided by x minus 3, my answer is going to be x squared minus x plus 2 plus 7 over x minus 3. Now over to the right, I've set up the same problem with synthetic division. Now first we'll talk about where these four numbers come from. these are the four coefficients of the polynomial right here. So there's a 1, which is a coefficient of the x cubed, -4 is the coefficient of the x squared, 5 is the coefficient of the x, and 1 is our constant. Now for this term right here, we're going to take the number that makes this object 0. So since 3 minus 3 is 0, we put a 3 there. You can also think about it as just being the opposite of this number that we have right here. And the way this algorithm works is we start by bringing down this number right here. Then what we do is we multiply here. So I get 3 times 1 is 3, and I'm going to write that number right here. And now I'm going to add between rows. So I'll say -4 plus 3 is -1. Okay? And then again I'm going to multiply 3 times this number. And I'll say 3 times -1 is -3. And again I add between rows. 5 plus -3 is 2. And then for a third time I say, okay, I'm going to multiply 3 times 2, get 6. I add between the rows and I get 7. And I'm going to put a little box right here. Now, if we look at this, this is actually our answer right along the bottom written out. Our answer for the division problem is that we've got an x squared, we've got a -x, we've got a +2, and we've got a remainder of 7, so 7 has yet to be divided by x minus 3. So you can see we've got exactly the same answer here and here. And if you look, you'll actually see these numbers in the middle here do show up in some of the intermediate steps in the long division problem. So the relationship in synthetic division, we ended up getting rid of the minus sign that was out in front. So we got rid of the negative that was right here. So we got rid of that. And then to compensate for that, we added between rows instead of subtracting. So synthetic division is a lot easier, but it really only works well for us when we've got a really nice little divisor, like x minus 3 or x plus 7. And we'll try a couple more examples of synthetic division. In this division problem, I'd like to take x cubed plus 2x squared minus x minus 2, and I'd like to divide that by x plus 2. And I'm going to do this using synthetic division. So I will go ahead and off to the left put my -2, which again is what I put in here to make this thing 0. And then I'll take the coefficients, and those coefficients are 1, 2, -1, -2. And go ahead and do my division. So I drop the 1 down. I multiply the -2 times the 1. That number is going to come up here. That's a -2. I add, I get a 0. Again, I'm going to multiply -2 times 0. That stays a 0. I add, and I get a -1. And again, I'm going to multiply -2 times -1, get +2. Add gives me 0. Now, all of these little arrows I'm drawing in here are not things you necessarily need to have or want. I'm just drawing them in as I'm working to help clarify what's going on. And, oh, that's interesting. I've got a remainder of 0, so that means that the answer to this division problem is, well, here we've got constants, here we've got our x's, and here we've got our x squared, so this is x squared. I could write plus 0x, but I don't need to, and I can write -1. So here's my answer to my division problem, and no remainder because, well, the remainder right here is 0. Alright, and this is actually a type of problem that we will come back to when the remainder is 0. It will end up being very important to us a little bit later on. And we'll do one more synthetic division problem here. I'm going to divide x to the 4th minus 2x cubed plus 3x plus 1 by x minus 3. So again, in the box off to the left, I'll put a +3. I'll put a 1, a -2. Now here is where people make mistakes. There's no x squared term. So I'm going to put a 0 in to remind me that I've got no x squared term there. I've got a 3 and I've got a 1. And we'll drop down the 1. 3 times 1 is 3. I add, I get 1. 3 times 1 is 3. I add, I get 3. 3 times 3 is 9. I add, I get 12. 3 times 12 is 36. I add and I get 37. So this means that the answer to my division problem is, well, here are constants. And I do recommend starting and making sure you recognize what each number in the bottom represents. Constant x's, x squareds, x cubeds. So I've got x cubed plus x squared plus 3x plus 12 plus 37 over x minus 3. So hopefully with those 3 examples, you're beginning to see how this synthetic division stuff works, because I'm about to give you an example to prepare for class tomorrow, along with a long division problem. So in this first problem, I'll ask you to use long division, divide the quadratic by the linear. And in the second problem, use synthetic division, and be careful to put a 0 in where you've got a missing term. So complete these for class, and I will see you tomorrow.